Our lesson today is to be able to write algebraic expressions. The essential question: how can you write an expression that represents an unknown quantity? In order to write algebraic expressions, we have to become familiar with key words or phrases that signal what operation we're going to have to use to write our expression. So these are some words that are commonly referred to when you're using addition or writing addition expressions: added to, plus, sum of, more than, increased by, total of, and the word and. All signal addition. Some subtraction words might be subtracted from or minus, difference of, less than, decreased by, fewer than, and take away. Those are all words or phrases that signal subtraction. Some multiplication words or phrases are multiplied by, times, product of, twice, or the word of. The word of always means multiply. And then for division, not as many, we have divided by and we have quotient of. A common error to avoid when writing expressions involving subtraction or division: the order of the terms is important. For example, the quotient of a number x and 2 means a number x divided by 2, not 2 divided by x. Alright, so let's take a look at some examples here. Let's start with problem number, or our first example. We want to take the word phrase and we want to write that word phrase as an expression. The word phrase says 8 fewer than 21. We have to recognize that the key words there are fewer than. That's going to signal the operation. But 8 fewer than 21 means we have to start with 21 and then we have to take away 8. That would be the expression that would represent 8 fewer than 21. Remember, with subtraction, the order of our terms is important. In the second example, the product of 30 and 9, right? 30 and 9. The word product means multiply. So if I put the 30 in parentheses next to the 9 in parentheses, that's how we would write that expression. If we continue, 14 more than a number x. More than is a phrase that signals addition. So 14 more than a number x, we would write as x plus 14, or I could write it as 14 plus x. With addition, the order is not important. So x plus 14 is going to give you the same value as 14 plus x. A number y minus 75, we would start with the number y, the variable, but then we would take away 75. So I would write that expression for a number y minus 75. The quotient of 3 and a number x. Remember, with division, the order is important, so I would write it as 3 divided by x, or we can write our division as a fraction. That would be 3 over x. Right, here are some that you could try on your own. Right, we'll do each of these one at a time. Problem number 1, the sum of a number 18 and 35. The key word there, or key phrase, is sum. So we would write 18 plus 35 because the word sum signals addition. Problem 2, 6 times 50. Right, that's going to be multiplication. So I'd write something like this: 6 and in parentheses 50, or I could put both terms in parentheses to signal the multiplication. Problem 3, 25 less than a number b. The variable has to come first if I'm writing that subtraction expression. 25 less than means we have to take 25 away from whatever the number b is. So b minus 25 is the only way we could write that expression. We have to be careful with subtraction expressions and division expressions, because that's where students are going to make the majority of their mistakes. Problem 4, a number x divided by 4. That's going to be the variable x comes first, over 4, or if you want to write it this way, x divided by 4, that would be fine too. Problem 5, the total of a number t and 11. The word total means addition, so I would have my variable t, and then we would add 11 to that. And then problem 6, we have 100 decreased by a number k, right? The 100 would have to come first, then the subtraction sign, and then our k, right? The order of subtraction is important, and 100 decreased by a number k, the 100 would have to come first in our expression. All right, here's a bunch that you guys can try on your own. All right, let's take a look at each one of these. 4 more, right? 4 more than a number would be 4 more than a number. I would have to write the variable n, and then 4 more than that, so it would be n plus 4. The difference of a number and 3, and we have to use the variable m. So the difference of a number and 3 would be the variable m, take away 3, because the word difference means subtraction. Next example, the sum of a number, and we want to use the variable x and 8, so that would be x plus 8. 10 less than a number, and we're going to use the variable p. So 10 less than a number p, the variable would have to come first, and then we take away 10. 7 units farther away, all right? Farther would mean addition, so we would start with our variable n, and then we want to be 7 more than n. 8 minutes sooner. Well, 8 minutes sooner, I'd have to take 8 away from whatever the time is, so we're going to use the variable t, but then we'd have to take away 8. 12 minutes later. Well, 12 minutes later would mean we'd have to add 12 to whatever the variable is, so it would be w plus 12. A number increased by 9. If we're told to use the variable y and we want to increase, that's addition, so y plus 9 would be the expression we would use there. All right, let's do the third activity, where we have to just match each expression with its word expression. The product of a number and 3, right, that's going to be here. The quotient of 3 and a number, that's going to be here. 4 times a number, 4 times a number is going to be here. A number divided by 3. A number, let's say the quotient of 3. Oh, I made a mistake. So let me redo that. The product of a number and 3, that one's correct. But the quotient of 3 and a number is going to be here. 4 times a number, that's here. A number divided by 3, that's going to be here. And twice a number would be 2 times a number. Alright? If we continue, the length of Interstate 90 from the west coast to the east coast is 153.5 miles more than 2 times the length of Interstate 15 from Southern California to northern Montana. Let m be the length of Interstate 15. Which expression can you use to represent the length of Interstate 90? All right. Well, 2 times means we're going to need multiplication. All right, and we have the plus 153.5. Right, so that's why it would have to be answer A. All right, and let's take a look at this example here. I want to do our table a little bit differently, so I'm going to erase this. Alright, so let's erase this. Let's get rid of all of that. And let's see what that's going to look like. And I want to erase this. Alright, and let's see how we do with that now. Let's make our own table. So if I'm making my own table here, it says make a table that shows the height of the tree for 4 years. We're told that the tree, when you planted it, it was 10 inches tall. Each year the height increases by 15 inches. So we would use the expression 10 plus 15 for each year, and then we want to use t. to represent the number of years. The variable is not so important, but they're asking us to use the variable t. So when we make a table, we want a column for the input, which is going to be our t, right? But then we need a column for the expression, right? I'm going to write expression. And then we're going to need a column for the height. Right, and the height is going to be, right, the output. So my input is going to be what? It says make a table to show the height of the tree for 4 years. So that would be year 0, year 1, year 2, year 3, and year 4. So it should look something like this. Year 0, we would have 10 plus 15 times 0. Well, 15 times 0 is 0, plus 10 is 10, meaning the moment it was planted, it's going to be 10 inches high. Now after one, year? Each year. So it's going to be 10 plus 15 times 1, 10 plus 15 times 2, 10 plus 15 times 3, and 10 plus 15 times 4. So we make a table of our input, we write the expression, we show how we're replacing the variable with the number, we're showing how we evaluate the expression, and then our output. 15 times 1 is 15, 15 plus 10 is height of 25 inches. 15 times 2 is 30, 30 plus 10 would be a height of 40 inches after 2 years. 15 times 3 is 45, plus 10 is 55, so 55 inches after 3 years. 15 times 4 is 60, plus 10 is 70 inches, right? Those are inches after 4 years. Evaluate the expression for when t is equal to 9, so that's going to be 10 plus 15 times 9. 15 times 9 is what? 135. Right, that's going to be 90 plus 45 is 135 plus 10. It's going to be 145 inches would be the output. Okay. Let's see what we have here for problem 7. Your friend has 5 more than twice as many game tokens as your sister. Let t be the number of game tokens your sister has. So 5 more than, oops, let's undo that. Right, it's going to be 5 more than twice the number of game tokens, and that's going to be t, that your sister has. Write an expression for the number of game tokens your sister has. 5 more than twice the game tokens. So for number 7, it would be 2 times a number t plus 5. Problem 8, it says in example 4, what's the total height of the cypress tree after 16 years? So that would be 10 plus 15 times t is the expression. So we're going to replace t with 16. So that's 10 plus 15 times 16. Well, what's 15 times 16? Well, 15 times 15 is 225. 225 was, so that's 240. 240 plus 10, it's going to be 250 inches. All right. And that's the end of the lesson here. Right, so just remember to use and look for those key words when we write the algebraic or the variable expressions.